children, welcome to Merry Mopeds Guild, fun and exciting STEAM learning lab. We have been learning that magnet attracts iron particles, iron, nickel and cobalt. We have also played with these magnets and we always have fun with magnets and attracting these iron particles. We have also observed that fruits, aluminium or gold, silver particles, they are not subject to magnetism. Are they really non-magnetic materials? No, they aren't. They also are subject to external magnetic force. So we are going to learn about that today, and the name of the experiment today is magnetic fruit. And for that we need 2 apples. You can also take 2 small grapes, a skewer, a twine, a hanger. You can also tie this twine to any object so that it gets suspended if you are not having the hanger, and a strong magnet. So let's start with the experiment. We are going to poke this skewer and on the both ends, and then we are going to tie this twine in the center, exactly on the center. Doesn't really need to get balanced. We are going to suspend it like this. I'm going to tie it on the chair so that it is easy for you to view. So I have hung it in the chair with the help of the hanger like this, and let's wait for it to become stable and we will move ahead with the experiment. Now that the apples are stable, now we will move this strong magnet and see what's happening. Can you observe? The apples are repelling the magnets. When an external magnetic force is applied, now let's again wait for the apples to get stable and we will try on the other end. I'm not really touching the apples. Slowly they are getting repelled and they start moving, and there is very weak repulsion which can be observed, and that is called diamagnetism. Diamagnetism means that the material is repelled by an external magnetic force. it is very weak that we will not be able to see it when we are holding the apple in our hands. There should be a pendulum like this, a torsion pendulum set up like this, so that this weak magnetic force can be observed. So when we hold it in our hand or keep it in a surface and try to repel it with the very high magnetic material, we will not be able to observe this. Now when you can observe slowly, very slowly, the magnets repel, the fruit repels the magnetic force. And this magnetism is not permanent. Hence it is weak. It can be observed only when other types of magnetism are totally absent. When diamagnetic material is introduced between these pole pieces of magnet, it spreads at the right angle of the magnetic field. It moves away. The material which is inside the apple is mostly water and carbohydrates. So water is a diamagnetic material. Materials like copper, silver, gold, zinc, graphite, air, hydrogen, alcohol and fruits are diamagnetic material. Fruits are diamagnetic material because there is more water content in the fruit, and water is a diamagnetic material. You can observe that the fruit is repelled by the external magnetic force which we are applying. So diamagnetic materials may be solid, liquid or gas. Gas like air, hydrogen. So this is called diamagnetism. Let's also learn about paramagnetism with the help of aluminium foil. This is the same setup we are going to use. Now you can clearly observe, because we are giving the magnetic field for a longer time. Now we will be able to observe clearly that the apples are repelling the external magnetic force. Now let's remove these apples. And we will add in the aluminium foil. Now I have attached aluminium foil. I have made it a ball and I have attached it to the skewer. Now let's observe what is going to happen when we are giving the external magnetic force to the aluminium foil. What do you observe, children? Aluminium foil is slowly getting attracted to the magnet. Let's observe on the other side also. So why is this happening? This is because of the paramagnetism. Paramagnetism is a form of magnetism where some materials are weakly attracted, very weakly attracted by an external magnetic field. They lose their magnetism when external magnetic field is removed. So they are not permanent magnets. When paramagnetic material is introduced between the pole pieces of magnet, it spreads in the direction of the magnetic field. That means it is getting attracted, as you observe, it is getting attracted to the magnetic field. The best examples for paramagnetic materials are aluminium, sodium, calcium, oxygen, tungsten and manganese. So what will happen when we introduce nickel, cobalt and other materials like ferromagnetic materials to the magnet? It gets attracted immediately. So these are ferromagnetic materials. Ferromagnetism is a phenomenon in which certain materials attain permanent magnetism. So when external magnetic field is applied to these ferromagnetic materials for a period of time, they become permanent magnets. And when they are removed also, they retain their magnetism, unlike these materials like aluminum and fruits, oxygen, hydrogen, which are diamagnetic or paramagnetic materials. So best examples for ferromagnetic materials are iron, nickel, cobalt and rare earth magnets. So when a ferromagnet is suspended in a uniform magnetic field, it comes to rest with its length parallel to the directions of the field. So now we have learnt about paramagnetism, diamagnetism, ferromagnetism, and we have observed that these materials also are magnetic materials. Fruits are also magnetic materials. Hope you loved this experiment. Bye children.